Hi there, I'm Luke with the Bulldogs Robot in 3 Days here at Kettering University, and I'm going to be talking about our intake and indexing system.
Your destination for first content, updates, and gaming.
Welcome to the fun.
Thank you to Kettering University and Stryker Careers for their continued support. Learn more at the end of this video.
So to start off with our intake down here, like we've mentioned a couple times during the stream, we have implemented the Thrifty 2-inch squish wheels and then the Rev 2-inch, they're compliant wheels. So we don't have our bumpers on right now, which gives us a little bit different results, but overall this is what we're planning on using for actually getting positive control of the cargo. Now on the inside, you'll see a lot of orange runs. These are polycord belts that we have been using to index the cargo inside of our bot. So as you can see, this one right here, we have one that spins horizontally side to side within our bot. So this pretty much makes it so that if we do end up intaking two cargo at once from our intake, since it is pretty wide and able to get a lot of control of the cargo, then one will go straight back in the main indexer and the other will go from the side over, and they won't kind of jam in our bot. So we have our main indexer right here. This runs straight to the back of the robot. And then lastly, we have our uptake. So this is two separate runs. We wanted to try out using an infinity shape of polycord to be able to reverse this, this rotational motion from one run to the other. But we ultimately decided that we weren't going to try that since there's a lot of force that was actually going through the system, and it is kind of frictioned overall since we are compressing the cargo, and they're not fantastic at compressing. They do compress a bit, but there's a lot of force withheld in them. So we ended up using two separate motors for these runs, just spinning opposite directions to make sure that the uptake takes the cargo from the bottom of the bot all the way up to our shooter. So a couple of the key notes that we found when we were assembling this indexer. First of all, you might see that some of our polycord is a little bit less elegant than you might be able to create in 6 weeks, I hope. We have a lot of zip ties that kind of function as barriers so that the polycord doesn't slide off side to side. This worked a little bit, but kind of depending on the pressure of the zip ties, it didn't completely do the job all that well. So we would definitely recommend using some sort of pulleys or different application than just a little barrier like that when you're implementing something like polycord. Secondly, we have the zip ties that are holding the polycord together rather than us welding it together. This somewhat worked out. It didn't give us too many issues, but you got to watch out for binding. I definitely recommend welding if you have the proper resources and tools to do so, though. Also, when we were getting everything together, we ended up using these somewhat of tracks for some of them. We tried out different implementations, of how we would keep the polycord together, and we did find that it would kind of slip off of these tracks if we weren't too careful, since the cargo has a lot of outward force overall as well. We found that overall the cargo is pretty well maintained by this polycord, and I think we would like to recommend it if you are trying to get the cargo from one place in your bot to another, but definitely be sure to watch out for a lot of the different binds and obstructions to their paths inside of the bot when you're doing so. But we found that overall it gave us a pretty solid method of transporting it from one place to another. Just be sure to watch out and make sure you're constantly engineering, constantly testing, and improving your design to make sure that you're doing it very optimally and give it those real-life match conditions so that you are really giving it a lot of brute force and it's able to withstand all of that, and you have a nice, robust design. Once again, this has been Luke talking about the intake and the indexer on our Robot in 3 Days here at Kettering University, the Bulldogs. And be sure to check out YouTube for more on our progress.
Thanks to Kettering University for their support of this video. Over 1/3 of Kettering's current students are former robotics team members. Go pro at Kettering University and get a free t-shirt. Students in grades 8 through 12 and located in the continental US, scan the QR code and complete the form by January 31st, 2022 and receive more information about Kettering. Thanks to Stryker Careers for their support in this video. First alumni and mentors are making Stryker a top priority for their internships and careers. That's because Stryker knows that those in First are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. Thank you to Annie Mark, Rev Robotics, and the Thrifty Bot for being official suppliers of the Bulldogs robot in 3 days. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.